Welcome back, everyone. Next, we have ASP Isotopes Inc. It trades on the NASDAQ under the symbol ASPI. It is a pre-commercial stage advanced materials company dedicated to the development of technology and processes to produce isotopes for use in multiple industries. Happy to bring back the CEO, Paul Elliot Mann. Nice to see you again, Paul. How are you today?
Yeah, I'm good, thank you, and thank you for having us on your webcast today. So I'll go over a few slides first of all, and then we'll get to some Q&A afterwards. So this is some forward-looking statements. So we're a publicly traded company on NASDAQ. So if you just review those, that would be great. And let's move forward to the meat of the presentation. Right. So what do we do? So our company produces isotopes, which are a very special form of chemical. We'll talk about those in a few moments. But isotopes are used every day. You touch an isotope almost every day of your life. You may not know it, but you do. They're used in things like quantum computing, oncology treatments, diagnostics, medicine, nuclear power generation, all kind of things that enable everyday life. And the real challenge for the world right now is that, or certainly for the United States, is that there's no domestic producer of stable isotopes. Russia produces about 85% of the world's stable isotopes, and Europe about 15%. But there's no domestic US producer of stable isotopes. And what is an isotope? Well, an isotope is basically a chemical that has a different number of neutrons to another identical chemical. So the chemical properties of a chemical are determined by the number of protons in the nucleus. That determines its position on the periodic table, which is what makes hydrogen different from carbon, that makes carbon different from chlorine. That's really determined by the number of protons in the nucleus. But different forms of carbon may have different numbers of neutrons in the nucleus, and that gives them very different physical properties. And they're very hard to separate. So we separate them by mass, typically. And it may sound easy, but actually it's quite complex ways of doing it. And when you think about silicon as an example of an isotope, silicon has 3 stable isotopes, 3 different masses. One has a mass of 28, the other 29, and the other 30. So when you dig sand off a beach, 92.2% of that silicon will have a mass of 28, 4.7% will have a mass of 29, and so on. A kilo of silicon, a kilo of sand is probably $1 a kilo, that kind of number. When we enrich silicon-28 in the 28 isotope, we sell it for more like $600,000 a kilo. For carbon-14, take a kilo of carbon, so a kilo of charcoal, for example, it's probably $1 a kilo as well. And when we enrich in the carbon-14 isotope, it's $24 million a kilo. So we take these really basic chemicals and we convert them into very special materials that have very special applications that the world kind of needs. So our company's been incorporated for 2.5 years. We acquired most of our technology out of South Africa via a business rescue process. And we have 3 kind of verticals or 3 business units in our company. In the middle, you see ASP Isotopes, and that's part of the company that produces stable isotopes. We have 2 manufacturing plants in South Africa. We're building a 3rd in South Africa right now, and our plan is to build more in Iceland next year, or later this year, actually. And our first 2 plants will start generating product and generating free cash flow around the middle of this year. So that middle vertical should be free cash flow generating around the middle of this year. To the left, you see PET Labs. We have 51% ownership in PET Labs. PET Labs is Southern Africa's leading nuclear medicine company. They supply majority of South Africa's PET isotopes. And that business has generated good free cash flow already. And our view there is, if that business can generate a 70% gross margin in a country where you have $6,000 per capita GDP, tell a business model elsewhere around the world, we can make a lot of money with that business. So our plan is to grow that business over the next several years. And we announced in November that we're going to triple the size of that business in South Africa over the next several years. And to the right, you see Quantum Leap Energy. And that's the business we incorporated in September of last year. And that's going to focus on producing the nuclear fuels of the future, specifically high-assay, low-enriched uranium for small modular reactors, and then lithium-6 for nuclear fusion. And that business has quite some way to go before it gets to cash flow break even. So in terms of our milestones for this year, our goal has been to secure at least 2 additional supply agreements to be supplied out of our South African facilities or to build new plants. And we hope to start building our first plant in Iceland later on this year. And then our second milestone is to get the company to its cash flow break even, generating free cash flow on an operating free cash flow basis. So how do we separate isotopes? Well, we have 2 technologies. The first is the aerodynamic separation process, and second is quantum enrichment. So on ASP, think about ASP as a stationary wall centrifuge. So we spin the gas inside a tube very, very quickly, approaching the speed of sound. And we then use special flow directors and flow nozzles to extract the light and heavy isotopes. And compared to a traditional centrifuge, which is a tube that spins around very quickly, we have no moving parts in our plant other than the compressors. The plants are much smaller in size. They're very capable of producing tens of kilograms of product. And they're much cheaper and easier and quicker to build. We can build a plant in 9 to 12 months, we think, whereas centrifuge is more like sort of 5 to 6 years. Our plants cost tens of millions of dollars, centrifuge likely billions of dollars. So they're the main things. The other advantage is that we can enrich light molecular weight gases as well as heavy molecular weight gases. And we signed a deal last week, actually, to supply silicon-28 to a large semiconductor company. And the main reason I think we're doing that rather than somebody else is because we can enrich silane, or the actual gas they want to use. And so that's another key feature of our technology. The second technology we have is quantum enrichment. That's where we vaporize a metal. So that's very good at enriching something you can't easily turn into a gas. We vaporize a metal, pass it through a laser beam, and the laser puts an ionized charge onto one of the isotopes. We can collect those isotopes then using a charge collector plate. Very good at enriching solids. So it highlights, very cost-effective, modular, scalable. You can grow the plant with size, and very environmentally friendly. There's no nuclear waste or anything from our plants. This chart here shows the isotopes that are of interest to us when we hope to start producing them. And many of these isotopes will be available later this year and early next year. And we've got a large backlog of interest from customers who require very specific isotopes. So this chart here talks about the changing face of nuclear medicine, how nuclear medicine has evolved over the last sort of 40 years, how it's going to change over the next sort of 20 years. And you'll see how we've moved from very basic diagnostic processes to now highly targeted therapies that can treat various cancers and other very complex diseases. And we'd like to be a big part of this nuclear medical industry. So this kind of shows how we can convert a stable isotope into a radioisotope, and that's what PET Labs does. PET Labs' role is to take a stable isotope and convert it to a radioisotope. And a radioisotope has a half-life of just sometimes a few hours or a few minutes, so you can't ship them very far. It's really as last mile of delivery taken to the extreme, or just-in-time delivery taken to the extreme. Fluorine-18 has a 120-minute half-life. You can't ship it more than sort of 2 or 3 hours. And you'll see that we hope next year to be able to produce carbon, molybdenum, zinc, nickel, and ytterbium, and they can all be converted into radioisotopes by a radioisotope producer such as PET Labs. Here's a picture of our first plant, carbon-14 in South Africa, and you'll see it's quite small in size. Each of those cases is about 2.2 meters high by 2 meters long by about 1 meter wide. And that plant will produce the entire world's demand of carbon-14. And our carbon-14 contract we've signed with a customer is for a minimum of $2.5 million take or pay a year. We expect to start supplying on that contract around the middle of this year. We announced that we've started processing the feedstock for this plant. We look forward to supplying the customer later on this year. Our first batch will take about 6 months to produce. Subsequent batches about 3 months to produce. We think molybdenum-100 is a very exciting isotope. The molybdenum-99 market today is about a $4.5 billion market. Molybdenum-99 has a 6.5-hour half-life. You're shipping it around the world, and every day, every 2.5 days, your product's losing half its value. molybdenum 100 is a stable isotope. It doesn't decay. You can ship it in a FedEx package, and you can convert to technetium-99, which is actually the element you want, at the point of care. We've had a number of advantages over this. We've got a lot of customers interested in being supplied with this product. Zinc-68, we kind of think zinc-68 is one of the key diagnostic elements for most new oncology treatments being developed, such as lutetium and actinium-based drugs. There's a real supply-side shortage of zinc-68, which is currently supplied by a generator. We think this is a great way of making it using zinc-68. We've got a lot of interesting customers for zinc-68. I'd expect our first plant in Iceland to be zinc-68. And then we just started building our ytterbium-176 plant in South Africa. That uses quantum enrichment technology rather than aerodynamic separation technology. And, we basically, we feel ytterbium-176 is a much better way of making lutetium-177. And we've got a lot of interest in this from many different customers who need supply fairly soon. And finally, silicon-28. We signed a contract, which we announced on Monday of this week, to supply a large semiconductor company in the United States with large quantities of highly enriched silicon-28. Silicon-28 compared to normal silicon used in semiconductors, it's per scientific papers, it's thousands of fold more conductive, and it also conducts heat about 100% better than normal silicon. So in order to make super fast, super cooled semiconductors to enable things like quantum computing, artificial intelligence, and other very rapid technologies or semiconductor technologies, people are going to need silicon-28 and other isotopes too, which we're talking to companies about. And so again, I think we would like to see ourselves as being the leader in this industry over the years to come. So as I mentioned earlier, we've got 2 plants in South Africa. We're building a third there. That'll be all the plants we build in South Africa. We expect to build most of our plants in the future in Iceland. Iceland benefits from extremely low-cost energy. That's our main cost. And so we look forward to starting to build our first plant there later this year. Our expectation is that most of our customers are going to pay for these plants in Iceland. We don't expect to have to pay for them out of ourselves. We expect the customer to put in a large deposit, and we'll then use that as a collateral to get a loan to build the plant. So let's talk about Quantum Leap Energy. So this is a business that's attracted a lot of attention recently. We've just raised $20 million into Quantum Leap Energy via a convertible note. That happened about 3 weeks ago. And so, listen, the problem is well known. The world needs more electricity. Data centers and electric vehicles are going to mean the world just needs a lot more electricity versus fossil fuels going forwards. Our view is that protesting is not going to solve this problem. Innovation and investment is what's going to solve this problem, and we'd like to be part of that innovation and investment process. I shouldn't have to explain why nuclear energy is so important, but very low carbon, footprint. It's controllable, it's constant, and also, solar and wind are great when you have sun and when you have wind. But if you don't, you've kind of got a problem. So nuclear fuel is really the only fuel where you can be guaranteed 24/7 kind of baseload production. In our view, the future of nuclear power is a small modular reactor. Think about what drove down the cost of a motor car. It was a Ford Model T, putting production line economics on a grander scale. This is basically taking production economics to nuclear power. So in the future, our expectations, you're not going to get 2, 3, 4 gigawatt nuclear power stations. The transmission grids required for those are huge. They typically go out costing $2 billion, taking 10 years to build. They end up costing substantially more. They way overrun, and there's a very, very significant track record of these projects never meeting economic goals or time goals. Small modular reactors are much simpler. Think of it like a 60-year battery. You can place it next to a city, power the city with that SMR. The leading companies in this space are companies like Terra Power, which is Bill Gates' company. That's X Energy, that's Cap Garfassian. There's Rolls Royce, and not shown here is Oklo, which is Sam Altman's company. And these companies have invested billions of dollars in these SMR programs. The problem for these SMRs is many of them require a new type of nuclear fuel called HALEU, high assay, low enriched uranium. Typically, reactors use low enriched uranium enriched up to 5%. HALEU is enriched up to 19.75%. And there is no Western production of HALEU today, or not in any quantity that can feed a nuclear reactor or feed this program. The Nuclear Energy Institute, shown here on the right, forecasts what the annual shortfall is in HALEU supply versus demand. We think that chart dramatically underestimates the actual number. We have customers who have signed MOUs with us who need collectively over $30 billion of HALEU by 2037. So we intend to use quantum enrichment for production of HALEU. And this chart here kind of shows in contrast different enrichment methods. So you'll see it towards the left-hand side a centrifuge. And the important line here to look at is the selectivity, the alpha. And so the selectivity of the centrifuge is about 1.15. There are many other ways to enrich it. Some towards the right look at laser type processes. And our preferred method is quantum enrichment, where the selectivity is much greater than 50. So it's 50 times more efficacious than a centrifuge. Think of it like that. And again, I mentioned earlier, what we do is we heat a metal up, we pass it through a laser, we ionize one of the isotopes and collect it on a charge collector plate. And this is quantum enrichment in real world. So here you'll see what was actually published in our Chief Technology Officer's PhD, which was published a number of years ago. This is the enrichment of lithium-6,7. So this chart on the right-hand side here, the top diagram, shows lithium-6 on the left, lithium-7 on the right. Lithium-6 is at 7%, lithium-7 is at 93%. One pass through our quantum enrichment process, and the lithium-6 has gone to over 90%. So what you're seeing there is an enrichment factor of over 112 compared to a centrifuge of 1.15. So, huge selectivity. We think it's very applicable to many difficult to enrich isotopes. And we started building our first QE plant in South Africa for ytterbium-176, and that should start up in 2025. So this shows what the nuclear fuel cycle looks like, and we're interested in the enrichment part of it. And as you'll see by these charts here, there's significant supply side stress on every single component of the nuclear fuel supply cycle right now. This industry's had little investment over the last 30 years. It's been constant oversupply of nuclear fuel. Russia and US down blending weapons grade uranium into normal uranium for nuclear reactors has meant massive oversupply of fuel. And 30 years of lack of investment and stable to flat demand go into an environment where you start to see single-digit demand growth and a supply-side shock, and suddenly people are scrambling to try and find more fuel. And this is a real problem for the world. Probably next year, it looks like there's not going to be enough uranium next year to feed the world's nuclear reactors. So how the world manages for that, I don't know. I don't have a crystal ball, but it's not going to end well, I'm afraid. What does this mean for HALEU? So, most of these reactors were designed and the economic plans put together, 10 plus years ago, when the expected price of HALEU was below $10,000 a kilo. Today, if a company could produce it using those market prices I just showed you a moment ago, a kilo of HALEU is going to cost more than $20,000 a kilo. So the economics of a lot of these projects are really being questioned right now. And I say, it's a problem. Because our enrichment factor is so high, we believe we can enrich depleted tails. So this is nuclear waste from someone else's enrichment process. So rather than having to buy feedstock, we expect to be able to get our feedstock either very cheaply or even paid to take it from someone else. And if we can do that, then that will allow us to really drop our cost of production dramatically. And that will allow us to make a substantially greater gross margin. and still be able to deliver fuel cheaply. And it's really important the world has access to cheap enriched uranium, because the only way you're going to drive nuclear adoption in emerging markets is if nuclear power trades at a discount, a green discount to traditional coal-based power stations. And in order to do that, we have to drive down the cost. SMRs drive down the capital cost. We're hoping this will drive down the operating cost with much lower cost uranium. So just to summarize, we have a proven and proprietary technology. It's been developed over the last 20 plus years in South Africa. There are many geopolitical tailwinds favoring rapid expansion, and there are a long backlog of customers wanting specific isotopes. As I say, since the corporation just over 2 years ago, we've basically constructed 2 plants and we started to build our third. So I'll stop there and I'll take any questions.
Great job, Paul. We do have lots of questions for you. First of all, Robert says he's always enjoyed your conferences in the past and looking forward to this update from you. He does have a few questions. One, when Quantum Leap Energy is spun out potentially later this year, will current ASPI shareholders receive Quantum Leap Energy shares prorate to their ownership in ASPI?
So the answer to that is yes. Our goal is to spin some shares out to our shareholders. The exact number of shares shareholders will get will depend on tax considerations. Our goal is to make this as tax efficient as possible. And so we will likely make an announcement later on in the year when we have a better idea of how much we can spin out to shareholders. But our goal is to give our current shareholders some of those shares.
And can you talk about the status of your 10K?
Yeah, so we've been delayed by a couple of days. I'm guessing they'll get filed very soon. We made a small acquisition in South Africa in October last year, November last year, and we've been trying to getting a valuation done for that in South Africa by a US accountant. It just takes a little bit longer than we were hoping it would, but. Nothing unusual, untoward going on. It just take a couple of days longer than expected.
Thank you for that. Howard asks, have you run into any unexpected hurdles, whether they be political, environmental, or material shortages?
Actually, political, environmental, no. I think we have a very good relationship with most political regulators and governments around the world. Material shortages, I think, actually are something that is affecting a number of companies, including, maybe not including ourselves so much, but something that we've had to pay much more attention to than I thought we would have to. So some of our feedstocks we kind of have to produce ourselves. We also fabricate most of the components for the plants ourselves, which basically mean we're not reliant on a huge supply chain. If that wasn't the case, I think we'd have had bigger problems building our plants. Our technology is very controlled, so we can't really give it out to third-party contractors to do for us. So so I say it kind of helps us. Things like compressors, heat exchangers, the timeline for delivery now versus the timeline for delivery 4 or 5 years ago. There's clearly, supply chain, is more tight than it used to be.
And Jeremiah Short asks, what does the semiconductor deal mean to the company from a revenue basis?
Yeah, we haven't discussed revenue numbers, but think about it as small. So, less than $1 million, that kind of thing. But I mean, there's many other customers wanting similar types of deals as well. So they could add up to become quite a lot over the next year or so. And then, in years to come, it could be substantially greater. Right now we're talking about single-digit kilogram quantities. We're talking to some customers about building a much larger silicon plant in Iceland, which could potentially do hundreds of kilogram quantities. So this is just a stepping stone to something much bigger, hopefully.
And Jesse Rowland asks, who are some of the current suppliers to the chip companies that you're competing with? And how do you beat them? Talk a little bit about your costs and the quality of product versus competition out there.
Yeah, so there are two other companies who claim to be able to enrich silicon-28 to the kind of standard that a semiconductor company requires for quantum computing. And let's be clear, this is not trivial. We're talking about 99.995% silicon-28, so enriched to just 50 parts per million of silicon-29. And semiconductor companies want it delivered as silanes, SiH4. It's a silicon atom in the middle and four hydrogen atoms around the outside. So the two other companies that can enrich silicon, one is called Rosatom, which is the Russian Nuclear Energy Corporation, and the second is an Australian company called Silex. But neither of those companies can enrich silane. They both have to enrich other elements because light isotopes, these isotopes don't work in their process. So we have a big advantage over other companies that we can enrich these lightweight, light mass isotopes. And what semiconductor companies want is these light mass, lightweight isotopes. And so that's a big advantage we have. And I think that's one of the reasons why we're talking to so many of them right now, is that they realize that we can actually enrich what they actually want.
And Brito asks a few questions. One, can you give us an update on the B. Riley meeting?
Not really. No, we had 4 or 5 meetings with investors in New York, organized by B. Riley, and they were just standard investor meetings. So nothing unusual. We're talking to a number of underwriters or potential underwriters about the Quantum Leap IPO, and so I'm guessing we'll do a few roadshows with other brokers as well over the next several weeks or so.
And are you in talks with Rolls-Royce for HALEU?
Yeah, I can't really talk about specific discussions that are going on. What we have said is we've signed 2 MOUs with large SMR companies who collectively need about $30 billion of HALEU being delivered. And we're talking to 3 governments right now. It's logical to think that one of those governments is the UK. And obviously the UK government is very close to Rolls-Royce, but I'm also talking to obviously to the US and South African governments as well. So, but yeah, I can't really talk about specific customers.
And last question from Brito, Silex is out of HALEU production. So is that an advantage for you?
Yeah, I don't think they said they're out of HALEU production. I think what they've said is that they're not going to be going in for the tender offer that DOE have put together, the RFP that DOE have put together. And quite frankly, I'm not surprised by that at all, actually. The RFP doesn't look particularly attractive to any customer, any producer that has other potential customers. So we're actually focused much more on customers who've got much stronger balance sheets than the DOE, who are fully capitalized, who are ready to pay for immediate delivery of HALEU, rather than some hopeful HALEU bank that may or may not be formed in the future. We will supply them if needed, but yeah, I think I wasn't that surprised actually by Silex's announcement last week.
And Chris says, regarding a recent purchase agreement by a semiconductor company for silicon-28, can you shed some light on when shipments will begin and approximate revenue potential?
Yeah, so as I said to you earlier, this is a small deal, so think about it being less than $1 million, but there's potentially quite a few more of these deals with other customers, we're in talks with. And, we'd expect to ship the product and receive cash for that shipment during 2024.
Spencer asks, do the ASP or QE processes create hazardous waste byproducts? If so, what's the cost and method of disposal?
Yeah, so for all the isotopes we enrich in ASPI, there's no hazardous waste produced. There are tails or unwanted streams produced, but they're not really waste. We don't have not a disposal problem or anything.
Aaron Martinez says, in the last Emerging Growth Conference you joined us with, you stated that the share structure would be a 1-for-1 when you spin off Quantum Leap. So is this still your plan?
I'm not sure I've ever said 1-for-1, but I mean, the goal is to make it as close to that as possible. And it's going to come down to the market cap of Quantum Leap versus the market cap of ASPI versus tax considerations and how much we raise and so forth. So I would never be able to comment on or confirm it's a 1-for-1, but our goal is to make it as much as possible. We spend as much as possible to shareholders. It might be more, might be less, I don't know.
And have you ever produced HALEU using depleted tails from reactors?
We have not yet, no. And actually, tails don't really come from reactors. Tails come from other enrichers. So if a nuclear enrichment company, a centrifuge, produces a kilogram of low enriched uranium, they actually buy about 6.5 kilograms of ore, and they produce 5.5 kilograms of tails. And we're taking those tails to enrich to HALEU. And we've not done it yet. We've only done lab scale production or lab scale enrichment of these products to date.
Caleb Bush asks, how about employee shortages? Have you had any trouble finding and securing good talent?
You know, operating mainly in South Africa, we have abundance of good talent, actually. South Africa is one of the top nuclear engineering countries in the world, I would say. They've got 4 universities offer nuclear engineering. We hire at least 5 or 6 graduates every year. We hire probably the 5 best chemical engineers and electrical engineers every year. We have not lost a single employee since we started the company up from them deciding to leave. And I say actually the DOE just sent 30 students from the US to Northwest University to study nuclear engineering in South Africa because those skills are not available in the United States. And so we're very lucky having access to that kind of workforce. They're young, they're keen, they cost probably a quarter to a third of the price of a US employee, and they work 8-10 hours a day. You know, when I look at the youth of today coming out of US universities, it would be challenging to replicate what we've done in South Africa in the US.
True point. Last question for you. Scott Murphy asks, how many different plants do you have? Is that sufficient so you don't need to spend money on production for the foreseeable future?
We have 2 plants in South Africa that are either complete or either in production or complete in production or in commissioning stages. And we're building a 3rd in South Africa right now. You know, we will likely build more plants in Iceland starting this year. We prefer smaller plants, lots of smaller plants rather than single large plants. It makes it easier to produce smaller quantities of isotopes. And because our capex is so much lower than a traditional centrifuge, you know, the capital efficiency of our business is much higher than most other players.
Well, Paul, do you have any closing remarks for our viewers today?
Yes, thanks ever so much for your interest and your questions. And I look forward to speaking again in the future.
Wonderful. Always great to have you on. We appreciate it. We'd love to see you back in the near future. Thanks, Paul.
Bye.
All right, everyone, stay with us. We'll be right back at the top of the hour with Alpha Cognition. We'll be right back.